Mr. Norwood here, and we're talking about complements after having talked about probability for a little bit. So complement's a funny word here. But if you remember, we calculated the probability of an event happening as the number of ways the event can occur over the size of the sample space, so we created a fraction. But this is all the ways E happened. Okay. The complement is pretty much almost exactly the opposite. First of all, if we decide that E is an event, the complement takes on the notation of E, and it looks like an exponent of C, superscript C. So E to the C, that's the complement of E. And in terms of the sample space, we just say that's not E, or everything that falls outside of that description. So everything works the same, but we can say the probability of the complement of E would be 1, the guarantee, minus the probability of E. So that would add up very nicely. So two ways we could do complements. We could either go in and find everything that doesn't fit what we're looking for, or we could go in and we could just take away what we already know. So let's see here. The first example. Jerry is told the probability of winning a certain card game is 0.045. What is the probability of losing? Well, winning and losing are pretty much the opposite of each other. So we could say the We could say the probability of losing is the same as 1, that's all the possibilities, minus the probability of winning. So we could say it's 1 minus 0.045, which I guess would be 0.955 in that case. So that would be the probability of losing. So if we know one outcome and we want the exact opposite of it, it's not very hard to discuss. So here is a little bit more detail, or maybe something a little bit more meat on it. So it says we have a random sample of 167 students based on their eye color, and you can tell from the chart it's based on eye color and gender. So we're going to say, what is the probability a student has blue eyes? So we could come in here, and we know the total is 167. We could add them all up. But there are 22 with blue eyes. So we could come in here, and that's very easy to get. Probability of blue would be 22 over 167. That may reduce, but I doubt it. So when it says, what is the probability a student does not have blue eyes? If we just answered that question, we're pretty much set with this one. But not having blue eyes would be kind of coming in here and adding up all the other ones, which would take us just a slightly bit longer than working with 22. But we can say it's 1 minus the 22 over 167, which if we do common denominator or even use a decimal, we can get to 145 over 167. So if you add those for the highlight together, they should give you 145, but it would be the same thing as taking the 167 minus the 22. So while this table is pretty small, if we had a table where there were 100 different outcomes and we wanted to just rule out one, we would hate to add up the other 99 when we could just subtract that one from the total. It's just a more efficient way if we have certain information already. So the last two things I've got down here, I believe. C, what's the probability a student is female with green eyes? So in that case, female with green eyes, it looks like there's 15. So I can call that 15 out of the 167. And when it says what's the probability that someone is other than a female with green eyes, we could go back and we could just take that away from the certainty, or take the 15 away from the 167, so we'd have 152 out of 167. So the complement and the way I talk about calculating it here is just for efficiency's sake. It also is pretty helpful if you're given limited information. Maybe you don't have details about everything, you're only given a certain amount. But think of the complement as not a certain set, so that leaves you with lots of options as how to calculate it. All right.